Gonna do a quick introduction and we'll get underway. My name is Gary Ray. I'm the market segment manager for Levitt Safety. I'd also like to introduce Alex Hilliker, Peter Ellefson, and Pam Korn from ChemDAQ. Alex is the vice president, Pete is the senior technical representative, and Pam is the marketing manager. We met with Alex and Pete about a year and a half ago to discuss a partnership in Canada and quickly learned that our companies have the same philosophy and passion for providing solutions to keep workers safe. The sole focus for ChemDAQ is to eliminate workplace exposure to peracetic acid, hydrogen peroxide, and ethylene oxide. This focus has allowed the ChemDAQ team to become a true subject matter experts in the field of sterile and gas monitoring. A big part of providing these solutions is education, and that is why you're here today to discuss chemical monitoring specific to the healthcare industry you are all part of. Our hope is that you will find this interesting and informative. There will be lots of time at the end for the presentation for questions and comments. Please use the chat or put up your hand, and I will turn things over to Alex and Pete.
Gary, thanks so much. It's great to be back with you again. I really enjoy doing these webinars with Levitt Safety. You and the team have been tremendous partners of ours, and we really appreciate the opportunity to chat with your customers and partners in Canada today about, quite frankly, a topic that is just not discussed enough, and that's worker safety from overexposure to chemicals that are used in medical device reprocessing. This is a critical topic, not just for staff safety, but for patient safety and efficiency in the hospital. So I just want to say thanks to you and the team, and thanks to everybody for joining this morning as well. I know that you've got a lot on your plate. It's a busy time of year. We do not take your time for granted. We appreciate you taking the time to learn a little bit more about this topic. And we're so grateful for the work that you and your teams do every day. It's a critical role in the hospital, and so this is a real privilege for us to be able to have this conversation. As Gary mentioned, my name is Alex Hilliker. I'm the executive vice president here at ChemDAQ. I run the day-to-day of our instrument division, and I also manage our partnerships like the one with Levitt Safety. And I spend a lot of my time doing this, really, these types of conversations, education, awareness, and discussion with the folks that are doing the work in the field each and every day. So it's an honor to be with you. Really enjoy this, look forward to this discussion, and look forward to your questions as well. And with that, I'll turn it over to my colleague, Pete.
Thanks, Alex. Yeah, good morning, everybody. My name's Pete Ellefson. Like Gary had mentioned, I'm one of the senior technical reps here at ChemDAQ. I do a lot with Levitt Safety as well as the majority of our customers here in the U.S. Similar to Alex, my passion is the worker safety side of things. It makes work really enjoyable when you're able to go out and make a difference and educate and teach people the risks and the harm that's associated with some of their day-to-day activities and show them that we really do care. And that's what ChemDAQ is. We're a company that cares. So looking forward to doing this with you all. We really enjoy this side of our business. It's one of our favorite things to do. And without further ado, we'll kind of get right into the topics today. So who we are here at ChemDAQ is really defined by our mission statement. We empower customers to eliminate workplace exposure to toxic chemicals. And we always like to stop there because the key to our business is empowerment. We're not a transactional company by any means. We want to help you guys find the problems that are in your area, make your operations more efficient, and really make a change for the better. In order to do that, we do that through our innovative monitoring solutions, our industry-leading partnerships like the one we're discussing today with Levitt Safety, and then our superior safety expertise. And where that superior safety expertise comes in is, ChemDAQ really takes a deep dive into the chemical monitoring space, but we do it for 3 specific chemicals and 3 specific chemicals only. It's very niche and very focused to exactly what you folks are doing on a day-to-day basis. Those 3 chemicals include ethylene oxide, which we're really not getting into a whole lot today, but it is really important. And then the main point of our topic today, which is hydrogen peroxide and peracetic acid. Um, Over here, you can see our values. Kind of like I had just said, empowerment's probably our biggest focus. We really like to touch on we're not transactional. We want to be involved with you guys, not just from the initial point of contact, but throughout as well, whether that's with our account management team or Levitt Safety, and coming on site. We want to make sure that, you guys are having all of the tools and technology needed to make those changes that are so necessary. Who we are again, we're a global company, so we have a global footprint that we're very proud of. We have over 600 customers that we're servicing around the world, on 5 different continents. So we stretch a little bit further than just the US and Canada, even though, that's kind of where we're located. And here in front of you, you can see kind of some of those customers in detail. And on the Canadian side, we do a lot with Vancouver Health, and then we do a lot with Lionsgate as well, just to name a few. So why ChemDAQ? We focus on what we call our big three. At the end of the day, our biggest worry and our biggest focus is safer workplaces. Our main goal is to ensure that all the workers that are using these chemicals daily are safe, and we do that through monitoring those chemicals. On the other side, we also look at the companies as well. We want to make sure that we're able to lower the risk that is there every day. And the risk we're talking about is the efficiency in your operations, whether that be ventilation or different things. We want to make sure that you guys are compliant with all the regulations out there, that you're not susceptible to a shutdown or any type of a citation. These regulations are in place, they're meant to be followed. And without something there to help you follow them, it can be very difficult. So we like to help with that. And then obviously next level protection. And when we discuss next level protection, it kind of goes back to that empowering stance that we've always focused on. We want to empower you guys with the data and information that you're able to gather with ChemDAQ's equipment. And we also want to make sure that we have partnerships around the globe, like our one here with Levitt Safety, where we're able to have more access to you guys and easier communications to provide you that protection that we're discussing. So objectives today. Number one, we want to outline the evolution of chemical use, specifically in sterile processing. So we're going to talk about the move to hydrogen peroxide, some of its benefits and the reasons why, as well as the move from glutaraldehyde to peracetic acid. By doing that, we want to make sure that everybody understands all the chemicals that are found in sterile processing, what they're used for, and what the risks are as you use those chemicals. We're also going to provide you guys with some practical work strategies as far as what you can do to manage or eliminate the exposure risks while using those chemicals, and then to explore the monitoring technology and safety resources that you guys have at your fingertips, whether you're aware of them or not. We want to make sure that everybody knows what's out there. With that, I will pass this over to Alex. Alex will take a deep dive into the evolution of the chemistry and the chemicals that you guys are using. So Alex, go ahead and take it away.
Thanks, Pete. So we always like to start these types of conversations with a little bit of history. Some of you that are watching today or watching on demand in the future are new to medical device reprocessing. Some of you may have been working in the industry for 30 plus years. And a lot has changed over the last several decades in terms of both the chemicals that we use, but also the technology and the machines that are used each and every day in the department. So we want to talk a little bit about the history and about that evolution, and of course the impacts that has on occupational health and safety for all of us working in and around sterile processing. So we start with ethylene oxide. The reason that we do that is that ethylene oxide, for those of you that are less familiar or not familiar, simply put, it's the most effective chemical sterilant known to man. It was, and in many ways still is, the gold standard for low temperature sterilization, really around the world. Many might be surprised to learn that Ethylene oxide is still used to sterilize more than half of all medical devices in the United States today. That's more than 20 billion with a B devices each and every year. ETOs showed up in hospitals around the 1950s to sterilize heat and moisture sensitive items. The chemical itself has great material compatibility and it's an excellent penetrant. And so really what that means is you can sterilize medical devices that have intricate designs, hard to reach areas, electronics, a wide array of materials and components. You can sterilize them very, very effectively. ETO is so powerful that you can actually sterilize products in their final packaging by the pallet. That's how powerful this sterilant is. The challenge with ethylene oxide is that it takes a really long time to aerate and off gas. That's because of that ability that it has to penetrate very deeply into the product. So it takes a long time for it to come back out, which can cause well-documented health impacts. So ethylene oxide is it's a known human carcinogen. It causes lymphoid and breast cancers. It's a mutagen and a teratogen. It can cause birth defects and miscarriages if you're overexposed. So as you can imagine, this was a real problem in hospitals because ETO was the best option for low temperature sterilization for a long time to ensure sterility and patient safety. But there's these major health concerns that come along with it. And so when we get to the 1980s, the 1990s, we start to see more regulations and stricter controls and requirements on the use of ETO, from monitoring to ventilation to medical surveillance on team members that are working with the chemical. And so, of course, you start to see the market react to that, and you see additional options and technologies start to be explored for low temperature sterilization. So enter hydrogen peroxide. Advanced sterilization products, ASP, introduced their STERAD product line using hydrogen peroxide gas plasma in the early to mid 1990s. Today, hydrogen peroxide is by far the most common low temperature sterilant used in hospitals in North America and really around the world. And so, people may wonder what made hydrogen peroxide a more favorable option to ethylene oxide. First and foremost, one thing we always like to point out is that cycle time really matters here. With ethylene oxide, it used to take 8, 10, 12 hours to sterilize one load. And that's because of all of the requirements that were put in place for ETO. You've got a precondition, you sterilize, you aerate. That took a really long time. Today, with modern H₂O₂, vaporized H₂O₂ and H₂O₂ gas plasma machines, you can do those same sterilization cycles in less than 30 minutes. So huge increase in efficiency with that decreased cycle time, moving from ethylene oxide to hydrogen peroxide. Of course, hydrogen peroxide marketed as a much safer alternative to ethylene oxide. Hydrogen peroxide does not have the same monitoring and ventilation requirements that ethylene oxide does. Generally speaking, the health impacts, the chronic exposure impacts are less severe with hydrogen peroxide than ethylene oxide. And it's very easy to implement. Really the hydrogen peroxide sterilizers that we're using today are generally plug and play. You need space and power. So you can easily see why hydrogen peroxide now dominates the market. On the high-level disinfection side, we share this because it's a very interesting and similar story to the evolution from ethylene oxide to hydrogen peroxide for HLD. So peracetic acid came about as the successor to a chemical called glutaraldehyde, which some of you may or may not still be using at your facilities. For those of you that may not be familiar, glutaraldehyde was the primary choice for high-level disinfection in hospitals since about the 1960s. It's a cold soak high-level disinfectant that also has a sterility claim if you let the device soak long enough. The problem is that glutaraldehyde vapors are toxic, and they can cause respiratory irritation, nausea, headaches, irritation to the skin if you're exposed, as well as a host of other health impacts. Glutaraldehyde is also what's known as a sensitizer, which means that with prolonged exposure, you can actually trigger a more severe response over time, the more you're around it. And so you see countries like the United Kingdom, for example, actually ban the use of glutaraldehyde due to the health risks to workers. And then you see a very similar shift as we saw previously. You see an increase in new technology and new chemistry, driven a lot by regulatory pressure and awareness of the health and safety concerns of overexposure to glutaraldehyde. So automated endoscope reprocessors came on the market. The Steris System 1, for example, offered really fast automated processing without the need for special ventilation and other requirements. And this was really attractive to the market, of course, because peracetic acid could be used that lowered the risk of toxic byproducts and toxic residue left on the product. And so AERs using peracetic acid have really taken over in high-level disinfection in most of our facilities in North America. And so I tell you all that. Thanks for bearing with me with the history lesson, but I tell you that to get to this. And this is really kind of the crux of the conversation today. Have the risks for chemical exposure really changed with the advent of this new technology and with the new chemistry that we're using? And in some sense, there's absolutely no doubt that it's a vast improvement to be using what we're using today, to no longer be soaking instruments in glutaraldehyde and open bins, manually aerating ethylene oxide sterilized loads in the department where we are light years ahead of that. But in some ways, we've really just exchanged one set of problems for another, we like to say. This is a really critical point. We're still using chemical biocides. The whole point of high-level disinfection and sterilization is to kill bacteria, kill the germs, right? And so the problem with that is these chemicals are really good at killing these cells, but they can harm healthy human cells just as well as they can harm a pathogen. They don't discriminate. And so that's the challenge that we're dealing with. We need to make sure that the instruments that we're using are safe for our patients. We also want to protect our staff at the same time. I think that's pretty easy for all of us to understand. So I think inherently there's no such thing as a safe sterilant or high-level disinfectant. There's only safer ways of handling them and managing and mitigating our exposure to them. And so when we think about the new technology as well, things that are being used today, I mentioned shorter cycle times as a key driver for the changes that we've seen over the last couple of decades. Shorter cycle times are great for hospital efficiency. They're less great for acute exposure to potentially hazardous chemicals if we're overexposed. Every time you open the door to a sterilizer, for example, you have the potential to be overexposed to hydrogen peroxide, for example. And then, faster cycle times also mean we have to use a higher concentration. We'll talk about that in a couple of slides, but we've got to use a pretty high concentration of these chemicals to get to the disinfection and sterility that we need to get to, again, to protect our patients. That's what it's all about. And then finally, even though the technology that we use today is designed to a very, very high safety standard, equipment failures can and do happen, as you see there on the slide. There's documented cases of this. Organizations like the Association for the Advancement of Medical Instrumentation, AMI, cite the fact that equipment can and sometimes does fail in their updated standards. It's something that we need to be cognizant of, prepare for the negative possibilities that could happen in ways that will protect our staff. So we're going to move into a section of the presentation now where we talk just a little bit about the occupational exposure limits for hydrogen peroxide and peracetic acid. Before we do that, I'd like to talk a little bit about the definitions to make sure we're all on the same page with what it is that we're talking about. Some of you, I'm certain, are familiar with these terms. For others, it may be the first time that you're hearing them. So we want to make sure we're all on the same playing field when we get into the next couple of slides of the presentation. So when we talk about an occupational exposure limit or a permissible exposure limit, this is the legal or regulatory limit for exposure to a hazardous substance, a hazardous chemical. These occupational exposure limits are typically expressed in terms of a time-weighted average because we're looking at the average of accumulation of chemical exposure that a team member is getting over a certain time period. That's how the regulations are written. That's how the health impacts are documented. So there's a long-term exposure limit. This is typically it's typically the same thing as an occupational exposure limit or a permissible exposure limit, a PEL. This is an 8-hour time-weighted average. So think over the course of your shift, what's the average level of hydrogen peroxide that you can be exposed to, for example, to be under the safe occupational exposure limits. There's also a short-term exposure limit, or STEL. This will be important when we talk about both of these chemicals over the next 2 slides. This is expressed as a 15-minute time-weighted average for exposure for a particular chemical. Then there's 2 other terms I want to make sure that we understand. The first is the immediately dangerous to life and health level. This is a term that is published by the National Institute of Occupational Safety and Health, NIOSH, here in the United States. This is the concentration that, as it sounds, poses that immediate danger to your life or health, or critically, and this isn't talked about a ton, prevents the escape from the situation. So if you're exposed to so much of an irritating chemical that your eyes are stinging and watering, for example, you may be approaching or surpassing that IDLH number because it might be difficult for you to find the door and get out of the room. And then finally, there's a level that's put out. This is for those of you that are familiar with the industry. If you're familiar with the American Conference of Governmental Industrial Hygienists, or ACGIH, they put out occupational exposure limits called threshold limit values, or TLVs. ACGIH has been around for a long time. A lot of the occupational exposure limits in the United States and Canada and really around the world are based on research and recommendations that ACGIH has put out over the years. Okay, so now we'll dive deep into hydrogen peroxide specifically. So what are the occupational exposure limits and health impacts of hydrogen peroxide? As you see on the slide, many people that we talk to are surprised to learn that the occupational exposure limit for hydrogen peroxide is the same as ethylene oxide at 1 part per million. This is true across all provinces in Canada, again, because they were originally derived from the ACGIH threshold limit values. These were put out in I believe, the early 1970s. And then you see the IDLH level there as well for hydrogen peroxide being significantly lower than ethylene oxide. That's because of the irritating nature of hydrogen peroxide as we get up into those higher concentrations. One thing that's interesting to point out is there's no widespread short-term exposure limit for hydrogen peroxide to account for acute exposures. There's a lot of reasons why that might be the case. I think those of you that caught me saying that the regulations are largely based on recommendations from the 1970s may be able to connect the dots there. But we know that inhalation of hydrogen peroxide vapor can be irritating to our respiratory tract and our eyes, also irritate the skin if you're overexposed. And part of the challenge with hydrogen peroxide is that it's generally odorless at low concentrations. And so similar to ethylene oxide, we don't know if we're being exposed or overexposed just by smell alone, because you can't smell it. And so the only way to know that is if you're monitoring, if you're testing the environment and you're seeing what's in the air. Of course, we recommend doing that in real time, but there's a lot of different ways that you can make that determination. There's also this misperception that overexposure to hydrogen peroxide isn't dangerous. And part of this is because it's such a common chemical. Hydrogen peroxide is everywhere. It's in shampoos and toothpaste and hair dyes. It's in the brown bottle that you buy at the pharmacy, at the drugstore, and put on cuts and scrapes and things like that. What we're talking about in those applications is typically say a 3% concentration in that brown bottle that you buy at the drugstore. In hydrogen peroxide, vaporized hydrogen peroxide sterilizers, for example, you're looking at 50% plus concentration inside that chamber. So it's really apples and oranges when we talk about hydrogen peroxide. As with anything, it's the dose, it's the concentration that informs the health impact there. I like to point out that even though there's not a a widely adopted short-term exposure limit for hydrogen peroxide that's in place. In the United States, for example, Washington State and Hawaii have implemented their own short-term exposure limit of 3 parts per million. Again, that's that 15-minute time-weighted average. And in Canada, there's a few provinces that have adopted this as well. Saskatchewan, the Northwest Territories, and Yukon, for example, have a 2 parts per million short-term exposure limit. This follows a trend that we're generally seeing an a growing international awareness of the importance of understanding the acute exposures of hydrogen peroxide. Countries like Japan, the United Kingdom, Germany, for example, and others are implementing these short-term exposure limits to account for these possibilities that our team members are being exposed when opening that chamber door. Which there are studies out there that show that can and sometimes does happen, as we've discussed. Finally, as you see there on the slide, hydrogen peroxide is a known animal carcinogen and a mutagen. So we absolutely need to make sure that we're handling this with caution and mitigating our exposure to the greatest extent possible when we're working in the department. Oxidized germs, not people, as one of my partners and colleagues likes to say. And finally, we'll talk about peracetic acid, and then we're going to zoom back out here after this slide and talk about knowing this information, having this awareness. What do you do about it? How do we address it? So peracetic acid, for those of you that might not be familiar, very common high-level disinfectant that's used today in automated endoscope reprocessors. It's also used in the food and beverage industry to prevent foodborne illnesses. And to sterilize bottles, believe it or not, before they're filled with product. So PA is pretty ubiquitous in the market because it's really good at what it does. It's really good as an antimicrobial. Unfortunately, similar to the other chemicals that we're talking about, it can cause respiratory irritation as well as eye and skin irritation. It's also been linked to occupational asthma and is a known sensitizer, like glutaraldehyde. And for those of you that may have joined late, a sensitizer is a chemical that can trigger a more severe response the more you're exposed to it over time. The problem with peracetic acid, for those of you who have worked around it, it's completely opposite of hydrogen peroxide. You definitely can smell peracetic acid. It's got a very sharp, pungent, vinegar-like odor because of the acetic acid component in it. I like to say our noses are not calibrated in parts per million. So it's hard for us to know if the exposure limits that we are well documented are being exceeded or not based on smell or odor alone. We also tend to go nose blind when we're working around peracetic acid, which means that the more you work around it, you might not notice it as much. Those of you that have kids in youth sports like I do, you know exactly what this phenomenon is. It's called olfactory fatigue. Think about when you walk into a locker room for your son or daughter and you smell what that locker room smells like. The kids don't notice it because they're around it all the time. Same phenomenon with working around peracetic acid, believe it or not. And so, you know, as we look at the slide here, there's no widespread occupational exposure limits in place for peracetic acid, but the American Conference of Governmental Industrial Hygienists, ACGIH, which again is the genesis for most of our modern day regulations, they recommend a 0.4 part per million 15-minute time-weighted average threshold limit value for peracetic acid. So this is a STEL, and organizations like AMI that I mentioned before reference this. Different Canadian provinces reference this ACGIH value. And then sometimes it's also referenced the EPA, the Environmental Protection Agency here in the US, puts out acute exposure guidelines, or AEGLs, for chemicals like peracetic acid. There's 3 tiers of those for PAA. Tier 1, which can cause notable discomfort or irritation, is set at 0.17 parts per million. These are all 8-hour time-weighted averages. Tier 2 at 0.51 parts per million can cause irreversible or other long-lasting health impacts. And then Tier 3, where we get to life-threatening health impacts, is set at 1.3 parts per million. So very low concentrations of these chemicals can have serious health impacts. And there is some evidence that these health impacts can be delayed after the acute exposure event as well. So All of that being said, I know that's a lot of information, but all of that being said, like I mentioned, we're now going to zoom back out and talk about how can we make sure that we adhere to the occupational exposure limits that are in place. How do we manage this and mitigate overexposure in our departments? And to have that conversation, I'll turn it back over to my colleague, Pete. Pete.
Thanks, Alex. So yeah, like Alex said, we're gonna kind of take a step back into the broader range of it and talk about how you guys can manage these chemical hazards in sterile processing. Most important thing you can do across the board, regardless of what you have in place, is to communicate this risk to the teams that you guys have in place. That can start anywhere from providing the SDS sheets to make sure everybody's aware of kind of the information and educational background of the chemicals, establishing emergency plans, mitigation plans, and most importantly, evacuation plans. If there is an incident, a leak, a spill, or an overexposure, we want to make sure that the risk associated with that has been communicated and that there's a plan in place to make sure that if that does happen, we're not having workplace injuries. We can still avoid injury even if there's an accident. And then something that sometimes gets overlooked with just the day to day is the labeling of chemicals. So obviously, when it comes from the manufacturer or the chemical provider, it's going to be in a tote or put into a bulk tank that's going to have those labels clearly visible. But if we're having to mix those or titrate things on our own and we have to move that around the facility, it's very easy to get that into a container that's not labeled, which is where we could see some other issues with someone walking up and maybe not knowing what it is. So labeling secondary containers is almost even more important. And then standard procedures. If there's PPE required, we want to make sure that that's in place, whether it be gloves or full smocks or SCBA available for the event of a leak or a spill. We want to make sure that all those plans are in place. That way the employees know what's going on and what to do. Excuse me. Something that also we always recommend is when you're unloading these sterilizers, for example, with hydrogen peroxide, um, something we see all the time is people opening the sterilizer and not taking a step back. It's very easy to just take that extra moment, open the sterilizer. If there's a monitor in place above that sterilizer, you could take a step back, see exactly what the exposure level is going to be, make sure that it's deemed safe, and then continue with what it is you need to get done. It's an extra few seconds, but in the event that a lot of hydrogen peroxide comes out of that sterilizer, it can really save the employee in the long run. And the same thing goes for PAA. Making sure that the employees have the PPE required. If they're doing exchanges on totes or different systems, do they have half masks or rebreathers available? Are they using gloves to make sure that if they do get that on their skin, it's not going to be irritated? So communicating with yourselves and your teams is crucial. Something else we like to discuss is the inadequate, as we like to call, monitoring options that have been out there. Like Alex had said, it's very easy to go nose blind or have that olfactory fatigue set in when using peracetic acid. We really like to focus on odor is not a reliable indicator of what those levels are. Kind of to reiterate what Alex said again is, our noses don't work in parts per million. They have no ability to tell you what that level is. They just may tell you that we don't like it. But the reason we don't like it could be that that level is too high. In order to know what that level is, we recommend having a fixed or a stationary monitor that's in place to tell you what those levels are at all times. Another inadequate thing is visual inspection for leaks or exposures. At the end of the day, what we're talking about here are gases. I don't know about any of you, but I can't see gas very well. So having something in place that's going to tell you exactly what those levels are is super important. We also recommend spot checking with portable monitors, which ChemDAQ does offer. Whether you have a large facility or a small facility, or different things get in the way of maybe mounting a stationary unit, we do have portable options that are available to be able to go around and check on the equipment or check in worker areas to make sure that you are staying within those regulations. I'm sure you all have seen this photo on the right here as far as badges. Badges have widely been used for a long time, especially in the sterile processing side of things. But it's not really giving you a good understanding of what your environment's actually doing. It's taking a snapshot, and then it takes a while to get that data back of what that particular snapshot is. If you've ever used peracetic acid, you know that during the day, sometimes that smell is stronger than other points during the day. So depending on when you gather that sample, it's only telling you that time of day. If it was in the morning, what's it look like in the afternoon? By having a stationary unit in place, you're going to know what those levels are at all times. And that kind of goes back to our empowering of organizations is we want you to have that data information of what your facility looks like on a day, a week, a month, so that you can really make those operations efficient and tie those things into such things as like ventilation, or air circulation and whatnot. Again, kind of the focus here, as you can see here with the sterilizer, is that fixed or stationary monitoring. The reason we really recommend it goes back to the AAMI ST58 standard, which was released last year, where they said, and we quote, that they recommend continuous monitoring for sterilant gases and high-level disinfectants for worker safety. What it's going to provide you is real-time concentrations of what those hazardous chemicals are in the environment. It's going to be able to give you the information that you're looking for regarding your permissible exposure limit, or your 8-hour time weighted average, as well as your threshold limit value or your short-term exposure limit at that 15-minute time weighted average. And it's going to be able to notify you and the team if those levels get to an unsafe marker. Whether that's with the visual alarm or the audio alarm, or you tie that into something else within your system, it's really going to give you the tools to be able to alert your team, hey, something's going on, you need to clear that area, and help avoid those worker injuries that unfortunately we've seen happen too many times. So what should you do now? Talk to your team and review what your existing monitor program or capabilities are. Go over your SDS sheets, go over your evacuation plans, your PPE. Really do a high-level takeover of your entire department and see, are you guys doing what is recommended to keep those folks safe while using these chemicals? Something else you can consider is a third-party clinical assessment, whether that be from folks at Levitt Safety or here at ChemDAQ, or even having an industrial hygienist come in and give you some real data and real tests that show what your environment looks like. Again, reviewing the communications of the training protocols. Is there a plan in place if something were to happen? And do your folks know what that plan is and how to take action with that plan? And then even further, we always recommend reaching out to your chemical suppliers, your equipment manufacturers, see what they recommend, see what they've seen in their testing of their equipment. Have they seen issues in the past? If they're willing to share, and they do share, you'll find, like Alex had said, that equipment does fail and accidents do happen. And the only way to be able to take care of that in a reactive approach is to start first at a proactive approach. And that's where we recommend continuous monitoring for these gases. At this point, I'll pass it back over to Alex to wrap things up and kind of open things up for questions and open discussion. So thanks everybody for listening. Really appreciate your time. Alex.
Yeah, thanks, Pete. Appreciate that. And thanks to Gary and the Levitt Safety team. We will have a few minutes for questions here. If you've got questions, feel free to put them in the chat. I actually think we got some in through email as well for folks that weren't able to join and want to catch this on demand. But, as those are coming in, I just want to say, one thing I really